In this video, we are going to learn about rational expressions and their operations. So let's begin with the definition of a rational expression. A rational expression is a fraction like ax over bx, where both ax and bx are polynomials. An example of a rational expression would be something like x squared minus 1 over x plus 1. So one of the operations that you should be able to perform is simplifying a rational expression. And when you're simplifying rational expressions, you're using factoring techniques. So for example, this rational expression here, if I want to simplify that, I can first factor the numerator. This is x minus 1 times x plus 1. The denominator is irreducible. In other words, you cannot factor that more. So I just repeat that, x plus 1. And now you can see you have x plus 1 as a factor in the numerator and x plus 1 as a factor in the denominator. So x plus 1 cancels x plus 1, and you have x minus 1 as the final answer. So that is simplifying a rational expression. Another example, 6x squared x plus 1 over 9x x plus 1 to the power of 2. Okay, so in order to simplify this, I can write this as, if I factor 6 and write it in terms of a product of its prime factors, 6 is 2 times 3, and then it's x squared, that's x times x, and that has been multiplied by x plus 1. And in the denominator, 9 is 3 times 3 times x plus 1 times x plus 1. And now you can see this 3 cancels this 3, and okay, I forgot one x here. Here we also have one x. Okay, now this x cancels this x here. X plus 1 cancels x plus 1 in the denominator, and I'm left with 2x in the numerator and 3x plus 1 in the denominator. So that is simplifying a rational expression. We should also be able to multiply and divide rational expressions. So assume that a, b, c, and d are polynomials, and you want to multiply a over b by c over d. The way you multiply them is very similar to the way you multiply ordinary fractions. It would be ac over bd. Okay, let's look at one example. If I have x over x minus 1, and I want to multiply that by x squared minus 1 over x squared. So this would be x times x squared minus 1 over x minus 1 times x squared. So it's AC over BD. But I need to simplify this, so I begin by factoring. If I factor the numerator, I have x times x squared minus 1 is x minus 1 times x plus 1 over x minus 1 times x times x. So x minus 1 cancels x minus 1, x cancels 1x in the denominator, and I'm left with x plus 1 in the numerator and x in the denominator. So that is how you multiply rational expressions. Now let's see how we divide rational expressions. So assume that we're going to divide a over b by c over d. Just like dividing ordinary fractions, I can transform that into a multiplication and actually multiply a over b by the inverse of the second fraction, that would be d over c. You just swap the numerator and denominator, and then this is a d over b c. So the numerator is the product of the numerators and the denominator is the product of the denominators. So let's look at one example. X to the power of 3 minus x over x squared minus 3x minus 4 divided by x squared minus x over x squared minus 16. Okay, so this equals x cubed minus x over x squared minus 3x minus 4 times x squared minus 16 over x squared minus x. So I transform that into a multiplication. My next step would be to factor every polynomial that I see. So for example, this one I can factor out 1x and I have x squared minus 1. From this other one, if I factor this, I get two factors x, because this is a squared minus b squared. This is difference of squares, so it's x minus 4 times x plus 4. You can see this one can also be factored. I can write this as x minus 1 times x plus 1. But let's do this one. Here I have a trinomial in the form x squared minus plus bx plus c. So I have to ask myself, what are two integers so that their sum is negative 3 and their product is negative 4, and those two numbers have to be minus 4 and 1. So x minus 4 and x plus 1. As you can see, the sum of the two is minus 3 and the product is minus 4. And the last one, if I factor that, I get a factor of x and then x minus 1. Okay, so this is not completely factored. As I said earlier, this can be factored to x minus 1, x plus 1. Let me do that. So I get x plus 1, x minus 1, x minus 4, x plus 4 over x minus 4, x plus 1, x, and x minus 1. Okay, now that it is completely factored, I can cancel the same factors from numerator and denominator. For example, this x cancels this x, x plus 1 cancels x plus 1, x minus 1 cancels x minus 1, x minus 4 cancels x minus 4, and I am left with just x plus 4. This is actually x plus 4 over 1, because as you cancel these, you have to replace them with 1. So the denominator is 1, but the denominator of 1 is always implied, so I don't need to write that. Okay. So let me give you another example of multiplication. X squared minus 1 over 2x minus 4 times x squared minus 4 over x squared minus x minus 2 times 3x minus 6 over x squared plus x minus 2. So I need to factor all the polynomials that I see. So this one is x minus 1 times x plus 1. This one here is x minus 2 times x plus 2. And here I can factor out 1, 3. So it's 3x minus 2. For the denominator, here I can factor out a 2, so it's 2x minus 2. Here I'm looking for two numbers so that their sum is -1, their product is -2, and those two numbers are -2 and 1. So x minus 2 and x plus 1. As you can see, 1 and -2, their sum is -1 and the product is -2. For this other trinomial, I need to look for two numbers so that their sum is 1 and their product is -2. Those have to be x plus 2 and x minus 1, because 2 and minus 1, their product is -2, their sum is 1. Okay, now that I have all the polynomials completely factored, I can begin canceling same factors from numerator and denominator. So I have a factor of x minus 1 here, x minus 1 here. I have a factor of x plus 1 here, x plus 1 here, x minus 2, x minus 2, and x plus 2, x plus 2. Is there anything left to be? Yes, I have this x minus 2 here and this x minus 2 here. So I'm left with just 3 over 2. Okay, you may have a division in the form of a complex fraction, like a over b over c over d. So if you have a complex fraction like this, this is a d over bc. So the only thing you need to do is to multiply the two polynomials that are farther away from each other, put that in the numerator, and the ones that are closer to each other, you multiply them and you put that in the denominator. So for example, if I have something like this, x plus 4 over x plus 1, the whole expression over x plus 4 over x squared minus 1, I can write this as a simple fraction. So these two, you multiply them, x plus 4 and squared minus 1. So the two polynomials that are farther away from each other, you multiply them and they go to the numerator. The ones that are closer to each other, you multiply them and they go to the denominator. So x plus 1 times x plus 4. Your next step would be to factor everything completely. So x plus 4 is irreducible, but x squared minus 1 can be written as x plus 1 times x minus 1. And then here you have x plus 1 and x plus 4 in the denominator. This cancels this cancels this, and I'm left with x minus 1. Okay, so that is how you do the multiplication and division operations for rational expressions. Now let's see how we add them and we subtract them. So again, very similar to adding and subtracting ordinary fractions. If I have a over b plus c over d, and here I'm assuming that a, b, c, and d are polynomials, this equals, in the denominator I have the common denominator. I have to multiply the two denominators, so the denominator is b, d, and the numerator is AD plus CB. So it's AD plus CB. Okay, so that's the formula we're going to use. Very similar to the formula we use when we're adding up ordinary fractions. For example, if I have 2 over 3 plus 1 over 5, this is 15. The product of the two denominators, and 2 times 5 is 10, plus 1 times 3 is 3, so the answer is 13 over 15. So the same concept is used when you're adding up rational expressions. For example, if I have x minus 2 over x plus 3, and I'm adding that to x over x minus 1. The common denominator would be x plus 3 times x minus 1. And then using the formula, AD plus CB. So A is x minus 2, D is x minus 1, plus C is just x times B, x plus 3. Okay, and then I need to multiply and simplify by adding the like terms. So this equals, let's multiply these two. We get x times x, so x squared, x times negative 1, negative x, minus 2x plus 2 plus x squared plus 3x over x plus 3 times x minus 1. This equals, okay, do I have any like terms? Yes, I have x squared and x squared here, so that gives me 2x squared. I have negative 2x here and 3x here, that gives me just plus x, so took care of that. No, wait a minute, I have a negative x here, so this and this and this cancel, so I don't have this part, plus 2. over x plus 3 x minus 1. Okay, now I can factor out a 2 from the numerator. That gives me 2 x squared plus it's a negative, no, that's a positive 2, so it's 2x squared plus 1 over x plus 3 x minus 1. Okay, let's check that. Yeah, 2x squared, and negative x and negative 2x is negative 3x, and I have a plus 3x here, so they cancel out, and I have a plus 2. Okay, so I have 2x squared plus 2. From that I factor out a 2. I get x squared plus 1 over x plus 3 x minus 1. And this is irreducible. I cannot reduce this, so this means that this is the final answer. Okay, so that's how you add up fractions. You probably remember from adding up ordinary fractions that it's sometimes easier in terms of the amount of computations needed to find a least common denominator when you're adding up or subtracting fractions. So let me show you an example in which we find a least common denominator instead of using this formula. So if I have x over x minus 1 minus 2 over x squared minus 1. So if I have a subtraction like this, the first thing that I should notice is that this can be factored. So the other parts, the other polynomials are irreducible, but this one can be written as x plus 1 times x minus 1. Okay, so if you use the formula that we talked about, you can always get the right answer using that formula, but here it would be easier to find a least common denominator. And the least common denominator between this denominator and this denominator is x plus 1 times x minus 1. Generally, the least common denominator, for making the least common denominator, you have to have all the factors that you see in all the denominators. So here I have a factor of x minus 1, I have a factor of x plus 1 and x minus 1. So there are actually just two factors, x minus 1 and x plus 1, and I have both of them in my denominator. So the way you make the least common denominator is that your least common denominator must contain all the factors present in all the denominators with their highest powers. So I will give you another example to explain that, but for now this is my least common denominator. My next step would be so I can write this minus x plus 1 x minus 1. I am modifying my two fractions without changing their value so that they have the same denominator. I can do the subtraction. So if you see, I had this, and now the denominator has become this one. So what happened? I multiplied x minus 1 by x plus 1. So I need to do the same for the numerator. So the numerator is x, I multiply that by x plus 1. So now this fraction equals this fraction, because generally I know a over b equals ac over bc. That is, I can always multiply both numerator and denominator of any fraction by a non-zero value c, and the value of the fraction does not change. So here I don't want to change the value of this fraction. So because I multiplied the denominator by x plus 1, I have to also multiply the numerator by x plus 1. Now this fraction equals this fraction. So for this other fraction, you can see the denominator hasn't changed, so the numerator doesn't have to change. So my next step would be to multiply these. X squared plus x minus 2, and I can use the common denominator x plus 1, x minus 1. Okay, as you can see, the numerator is factorable, and I need to factor that. The numerator can be written as x plus 2 and x minus 1. The sum of these two numbers, 2 and negative 1, is 1. Their product is negative 2. The denominator is x plus 1 times x minus 1. Now you can see this factor cancels this factor, and the final answer is x plus 2 over x plus 1. Okay, now let's look at another addition or subtraction problem. If I have x over x squared minus 1 plus 1 over x minus 1 to the power of 2. What would be the common denominator between these two denominators? So my first step would be to factor this completely. This gives me x minus 1, x plus 1, plus 1 over, this is already factored, it's x minus 1 to the power of 2. Okay, now what is the least common denominator between this denominator and this one here? So I have a factor of x minus 1. I also have a factor of x plus 1. So definitely my denominator, my least common denominator, must have both factors, x minus 1 and x plus 1. X minus 1, x plus 1. So as I said, the least common denominator must contain all the factors that you see in all the denominators. So I can see x plus 1, it must be present in the least common denominator. I can see x minus 1, it must be present. Now, the next step in building your least common denominator is that you have to use the highest power of each fraction, or of each factor. So the highest power of x plus 1 among all the denominators is just a power of 1. So x plus 1 to the power of 1. But for x minus 1, I have a power of 1 here, and I have a power of 2 here, and the highest between 1 and 2 is 2, so I use the highest power. So x plus minus 1 to the power of 2 and x minus 1 to the power of 2. So this would be the least common denominator among these two denominators. So as you can see, the least common denominator contains all the common and uncommon or non-common factors with their highest powers. Okay, my next step would be to modify the numerators as well, so that I don't change the value of the fraction. I need to check what happened to this. This denominator was multiplied by x minus 1. So I need to do the same for the numerator. The numerator x is also multiplied by x minus 1. Now you can see the value of this fraction is the same as the value of this fraction. I can easily cancel one factor of x minus 1 from numerator and denominator, and I will get the same fraction back. So for the second part, what happened to this denominator? It was multiplied by x plus 1. I need to do the same for this numerator. So 1 times x plus 1 is just x plus 1. So now I can use the common denominator, x minus 1 to the power of 2, x plus 1, and x times x is x squared minus x plus x plus 1. Minus x cancels plus x here, so I have x squared plus 1 over x minus 1 squared, x plus 1. And the numerator is irreducible, so we are done here. One other thing that I want to notice is that you should be careful when you are subtracting two fractions. For example, if you're subtracting, let's say the denominator is x minus 2 and you're subtracting x over x minus 2 minus 1 minus x. You should be careful about distributing this negative here. So here I have the common denominator x minus 2. For the numerator, this negative here affects the whole numerator. So you can put parentheses around 1 minus x. When you are doing the subtraction, you should be careful that this negative affects the whole numerator here. So it becomes x minus 1 minus x becomes plus x. So this is 2x minus 1 over x minus 2. And that's it for rational expressions.